So we've done evaluating functions. We're just going to do more of it today, a little bit of harder ones. But the concept is to take whatever's in parentheses and make a substitution. So I got a few examples here that I've already worked out because I know that we are really good at the numbers, but then I'll make sure I go step by step with the variables. So this first one says find p of -2 and p of 3. This means to take -2, substitute it into our function. Take +3, substitute it into our function. So I've already set that up for us. So the function that we're working with is x to the third minus x to the fifth. Every place we see an x, we're going to substitute -2 in, which I've already done. Use Desmos, plug it in. Every single place I see an x, we got to plug in the number 3. So I've already plugged in the number 3, use Desmos, and get our answer. So again, this is a little bit of a review, and then we'll do some harder ones in just a few minutes. Number 2 gives us p of x equals -x to the fifth plus 4x to the third. This is the function that we're using. The directions ask us, let me put a little star note here. These are the directions. Find p of -2 and p of 3. So we're going to plug in -2 and we're going to plug in +3 and get two different numbers. So we're on number 2. I'm going to substitute -2 in for the x's. Substitute it in, get my answer. And I'm going to substitute in +3 in for my equation and then get an answer. So you take whatever number they give you, make a substitution, use Desmos to get your answer. And I got one more here that I've already done for us. P of x equals x to the fourth plus 1/2 x to the third minus 1/2 x. Take your numbers, substitute them in. The directions asked us to do two numbers. It asked us to substitute -2 in. So every place I see -2, I'm going to get rid of the x. I'm going to plug in -2. I got 13. Every place I see an x, I'm going to get rid of the x, and we're going to plug in the number 3, use Desmos, and get our answer. So I just flew through those because we've done the numbers before. Today I want to focus on what to do if you're given variables. But pause the video if you need to write those down. Let's take a look at some harder ones. So now I have two functions down here. P of x equals 3x squared minus 4. And r of x equals 2x squared minus 5x. And number 1 wants us to find p of 8a. This means to take 8a and substitute it into p. Now, I know I needed to use p because there's a p on the outside. So it is pretty much that simple. I'm not working with this function. Just ignore it. I'm only working with p. So I'm going to take 8a and substitute it in for p. So if I make that substitution, every place I see an x, which I only see one of them, I'm going to get rid of this x and I'm going to plug in 8a. So that's going to give me 8a squared minus 4. Notice the x went away. The 3 comes down, the x goes away, the little 2 stays, the negative sign stays, the 4 stays. Get rid of the x, plug in 8a. Now I use order operations to simplify this. 8a times 8a, that's what it means to square something. That is 64a squared. So I'm using order operations. From here, now I can multiply. We're going to be multiplying 64 times 3. Use a calculator. So 64 times 3, I got 192. So this gives me 192a squared minus 4. And that is our final answer. So whatever is given to us in parentheses, you make a substitution and plug that into your equation. And I only use p because the equation, the problem had p. That's why I was not working with r. Let's try 2 more. Okay, so number 2. This time I'm doing -5r of 2a. So I'm going to do r of 2a and then multiply the whole thing by -5. So just for a moment, we're going to ignore -5 and we're going to do r of 2a. So this means to take 2a and make a substitution into my polynomial. So I know I'm using r because there's an r here. That's an r, this is r, we're going to make a substitution. So we're going to take 2a and I'm going to plug it in here and I'm going to plug it in here. So let's make that substitution. So that's going to give me 2, plug in, squared, minus 5, plus 1. So I used R because that's the problem that I started with. Every single spot that I saw an X, I made a substitution and I substituted in 2A. I am ignoring the negative 5 for just a minute. I'm only doing the inside part first. So we go through and multiply this. This gives me 2. 2 times 2 is 4. This gives me 10. 2 times 4 is 8. Okay. And the last thing I need to do is bring this negative 5 back out in the front. So we did R of 2A first. Now I'm going to take what we found and multiply it by negative 5. So multiply by negative 5. Now I'm going to use the distributive property to help me multiply. Negative 5 times 8A is 40A squared, and it's a negative. Negative 5 times negative 10A is 50A. And negative 5 times 1 is negative 5. So circle the end. And one more that we'll take a look at. So whatever they give us, take that and make a substitution into your functions. If there's 2 x's, make 2 substitutions. If there's 1 x, make 1 substitution. If there's 5 x's, make 5 substitutions. Okay. And the last one, number 3. Let me zoom out just a little bit so we can see both the functions. So I'm still using the 2 functions that are up here at the top. I'm still using P and I'm still using R. This time we're taking x squared minus 1 and we're substituting it into my P function. I know I'm using the P function because there's a P down here. So that's going to match up with this P function. So I'm going to get rid of this x and I'm going to make a substitution of x squared minus 1. So I'm taking x squared minus 1, and I'm making a substitution up here. So that substitution is going to look like the following. So I kept the 3. The 3 comes down. I kept the x squared minus 1. I substituted that in, rather. I kept the little 2, my exponent of 2. I kept the minus sign, and I kept the positive 4. Now we got to go through, and we got to multiply this out. You cannot do 3 times x squared 3 times negative 1. I need to do the box method or distributive property, and I need to multiply this out. So over here to the side, I'm going to do x squared minus 1 times x squared minus 1. So right now, I'm doing x squared minus 1 squared. So x squared minus 1 times x squared minus 1. I'm going to multiply this out. That's going to give me x to the 4th. Minus x squared plus 1. I got some like terms. That gives me x to the 4th minus 2x squared plus 1 because these are like terms. Now I can take this and I can make a substitution back into our problem. So x squared minus 1 is x to the 4th minus 2x squared plus 1. So x to the 4th minus 2x squared plus 1. And then the minus 4 comes down. So x squared minus 1 squared, we did that work off to the side. This is like our little side work. Then I took my answer and I made a substitution back into the problem. Now I can go through and do the distributive property. 3x to the 4th minus 6x squared plus 3 minus 4. So we multiply. 3 times x to the 4th, 3 times negative 2x squared, 3 times 1. Now I combine like terms, so my final answer is 3x to the 4th minus 6x squared minus 1. So final answer, 3x to the 4th minus 6x squared minus 1. So however many times you see the variable, you make a substitution into the problem. Sometimes you'll get a number back, sometimes you'll get a variable.